Hello everyone, welcome back. This is the lecture 4 of our CSES Dynamic Programming Series, and today we are diving into another interesting problem, and the problem name is removing digits. Okay, so grab your notebook, stay focused, and let's get started. Let me read the first Let me read the problem statement. You are given an integer n. On each step, you may subtract one of the digits from the number. Okay. How many steps are required to make the number equal to 0? Okay, we are given an input n and print the minimum number of steps. We are given n 10 raised to power 6. Okay, so let me just copy this example and pasted it here. Okay, okay. So we are given as n. In one operation, we can choose any digit from n and subtract it. Okay, so basically it means that in 27 we can select 2 or either 7 and subtract from the number. In this operation we will choose 7. Okay, so my number jumps to 20. Okay, so in 20 we have again two options. Either we can select 2 or either we can select 0. So we can select 2. Okay, so now my n is 18. For 18 we have also two options, 1 and 8. We will choose 8. Okay, so now our number will become 10. Okay, for 10 we have again two options, either we can select 1 or either we can select 0. Okay, so we choose 1 and the number jumps to 9. Now 9 is a single digit and we can choose directly. So I will subtract and 9, so it will become 0. Now the total number of steps to do it is 5. Okay, so I hope the problem statement is clear to everyone. Now we are moved to solution. Okay, so first we will understand why we are doing dynamic programming in this problem. This is very important to know this. Okay, let me just write the number 78965. Okay, suppose this is a number. Okay, we have various number of options to do the subtraction operation, right? Like in this end we have 3 plus 3 6 options to subtract this. Okay, either I can choose 7 8 9 6 5 3. Okay, so let me just take the smaller example so we can understand it better. I will take 7 8 6. Okay, so we have three options to do this. Okay, 786 minus 7, it will become 779. And if I choose 8 to do this, it will become 778. If I choose 6, it will become 780. Okay, for 779 we again have two options, either I can choose 7 or 9. Okay, if I choose 7, it will become 772. If I choose 9, it will become 770. Okay, as you can clearly see, we have various number of options. Okay, it is a long big tree. So in order to solve this problem, we have to use the dynamic programming in this problem. Okay, I hope this much is clear to everyone. Now we will be moving forward with our DP solution. First, we define the states of DP. DP of I represents the minimum number of steps to make the I equal to 0. Okay, dp of I represents the minimum number of steps to make the I equal to 0. Okay, so let me explain this. If my number is 11, okay, I can choose 1 to subtract. Okay, now my 11 will become 10. Okay, so for 10 we have two options. Either I can select 1 or either I can select 0. So I choose 1 and going move forward. Okay, so 10 will become 9. Okay, so 9 will now become a single digit. So I will choose 9 directly. Okay, 9 minus 9, it will become 0. So for 11, 1, 2 and 3, dp of 11 stores the minimum number of steps to make it 0. Okay, so how much it is? dp of 11 is equals to dp of 11 stores the 3. Okay, so first we will go through the recursive solution and then we will go to tabulation part. Okay, so if my number is given, like that 7, 8, 4, 6, 3, I will convert this number into my string. Okay, then my string length, maximum size of string length would be 6, because in the problem statement we are given that n is maximum up till 10 raised to power 6. Okay, so the number of digits in the string is maximum 6, so we can iterate now. Okay, so I will choose every number in this string like 7, 8, 4, 6, 3. I can iterate on this string and I can choose this number. Okay, so if I choose this, then I will recursively call. It will be much better if I show you my code directly for the recursive part and then go for a tabulation. Okay, so let me show you my code. Here it is, my code. Basically, it is very simple problem. Okay, if my number is less than 0, okay, then I will return max, because we have to make the number equal to 0. Okay, not minus 1, not minus 2, only 0. So that's why we are doing it. Okay, if my number is equals to 0, then I will return 0. It means that I will found a number which I will found a number and return a 0 count. Okay, it will be not contributing to my answer anymore. Okay, if I already calculated my dp of num, then I will simply return dp of num. Okay, i I think this much is clear to everyone. Okay, so coming to the next part, I will declare an answer variable to max size. Okay, I will convert integer num to string. Okay, then I will iterate in the string. Okay, then uh, I take that element into the string. If my element is greater than 0, okay, I will add 1 to my answer and then recursively call for next solution. Okay, it will give me a total number of ways to do it. Total minimum number of ways to do it. Okay, so let's understand why we are taking element greater than 0. If my number is look like this 0, 0, 8, 4. Okay, so my string length is 6. Okay, so for the this index I will subtract 7 minus number. It will become 7 7 0 0 7 4 3 7. Okay, it goes for recursive solution for this. Okay, now my index we will move to this index 0. Now if I subtract this number minus 0, it will remain as same. Okay, I will stuck in an infinite loop. Okay, we will keep going, keep going, keep going, because we are not subtracting, we are not reducing the number. Okay, So it will lead to a TLE or memory limit exceed, or as you can see. To avoid that TLE, we will take element greater than or equal to 0. Okay. Then I will store dp of num is equals to answer. Okay. So yes, that is a recursive solution for this problem. I will share a link in the description box. You can check this out. Now we are coming to the tabulation part. It will be much easier if you can implement yourself, but I can show you my code. Okay. So for tabulation, it will remain as same. Okay. Tabulation code. Yes. We will declare a dp of n plus 1 and initializing with int max because we have to calculate the minimum number of steps required to make uh, this the element 0. Okay, to make 0 we have 0, we we take only 0 steps. Okay, we will run a loop from 1 to till n. Okay, uh, basically we have to store for each ways. Like if I'm calculating for 11, I have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this much we have to calculate each one of them to get the minimum answer, minimum number of moves. Then I will create I2 string A. Then I will iterate on string and take the ith character. If it is greater than, then I will take the minimum of dp of I minus dj plus 1, and yes, that's the final answer stored in dp of n. I hope this video might be helpful for everyone. Thank you very much guys for watching this video.